We have our client and database server ready, and we have installed PSQL also in the client machine, and we have created Aurora database server. Now, to go ahead and work on SQL statements, we need to know the database objects. What database objects are there? So, the first thing is the database itself. So before creating tables or other things, we'll have to create a database. And what is a database? A database is a grouping of multiple objects. So typically what happens is that you will create separate databases for separate applications in the same cluster. Or you can create only one database in one cluster also, meaning one database server that you have just launched. Or there can be one or more databases also. So let's say you have decided to use only one database server and you have more than two departments, for example, so or more than two applications. So let's say you have a customer application, you have an order application, and maybe you have an order processing application. For all the three applications, you might decide to create three different databases just to logically separate them so that it aligns with the business data. So customer database would only contain data related to customer. The orders database might contain data only related to order. So you can create one or more databases in a single database server. Under the database, we create something called a schema. So a single database can have one or more schemas. Now, let's say if you decide to create only one database in the database server, then schema is a further logical grouping of the objects that you plan to create. Meaning, as I said, let's say there is only one database for the entire application. And what you do is that for customer, you create one schema. For order, you create another schema. And maybe for order processing, you create another schema. And under schema, we create tables and other things. So a single schema can contain multiple tables. So all these tables would belong to, let's say, schema 2. You can create other tables also under another schema. So these tables would belong to this particular schema, which is schema 3. Now, as you can see, the table names are same. Table 1, table 2, 3, 4, 5, 6. Schema 2 contains these 3 tables, or these 6 tables rather. And schema 3 contains table 1, 2, 3, 4. And the table names are same. That is fine because these tables are created under schema 2 and these tables are created under schema 3. As long as the tables belong to different schema, the names can be same. But if the tables belong to the same schema, the names have to be different. So the table names or the object names should be different inside of a schema. The names of the schema should also be different in the database. Apart from tables, we can have other objects like views also. And let's say we create two views under schema 3. So it might so happen that let's say one schema does not have any views, it contains only tables, and another schema contains tables and views both. That is perfectly fine, again, depending on your business requirement. How do you create these database objects? We use something called data definition language or DDL. So using DDL, we create these objects. For example, you create databases, we create schemas, we create tables and views. We can also modify the databases, schemas and tables and views. The creation, modification and deletion of these database objects are done using data definition language or DDL, which is also one form of SQL statement. Another form of SQL statement is DML or data manipulation language. Using DML statements, what we do is that we fetch record, we insert record, we update records, and we delete records. These are called data manipulation language. There's one more SQL statement that is called data control language or DCL, and it is basically used to provide authorization on these objects to a certain user. So let's say you have multiple users in the database. You can use DCL to grant different permissions to different objects. So in this particular SQL chapter, I'll not talk about DCL. I'll only talk about DDL and DML. Now, how do you create database and schema? What are the various operations that are performed on databases and schemas? The first thing is that we create a database and then we connect to the database, and then after connecting to the database, we create schema inside of it. Once the database is created, we can also alter it, meaning we can change certain configuration of the database, or we can drop the database completely. Drop is like deleting the database, so the entire database would be gone. Likewise, we can alter schema and drop schema also, and all these are done using DDLs. Now there's something called collation. So what is collation? Collation is a specification how the text data would be interpreted by the database, and based on that how the data would be sorted and ordered and stored. For example, let's say there are different languages. We have English, we have, let's say, Latino, we have Hindi. The interpretation of all these languages are different. Now, let's say we want to create a database for India, and in India itself, we have more than 1,000 languages. But we want to create, let's say, a database with different languages. So, for all those different languages, we'll have to create different databases. And for all the databases, the collation would be different. Similarly, let's say I'm creating a database wherein I will store data or text that uses Latino language. So for that, the collation of the locale would be different. And how do you mention that? We do that while creating the database. So this is the command to create a database. Create database followed by the name, and then we mention locale. Typically we use UTF-8 for most of the databases, and if you want you can use a different locale also. Now there are a lot of other configurations while creating the database, but as this is not an administrator course, I'm not going into the details of those. Then once the database is created, we can create a schema also. It is very simple, just create schema followed by the schema name. Then we can alter a database to change the configuration, or we can alter a schema, we can rename a schema, let's say. Then we can drop a database and drop a schema also. Now under database and under schema, as I had shown you in the diagram, that we create objects like tables and views. And tables are the main objects because tables are the places where we will store data. We'll insert our data in a table. We do not insert data in database. We do not insert data in schema. We create tables and insert data in those tables. So the tables are the places where our data would contain, our business data, organization data, everything would be contained in one or more tables. And it looks like this predefined structure, and all the rows would follow the same structure. This is what a table is. Now this is a visual representation. In database, the table is actually not stored like this, but as a developer, this is how we should visualize what a table is. It's a bunch of columns and a bunch of rows. And then we define the structure of a table. And what do I mean the structure of a table? How many columns would be there and what would be the names of those columns? So as I told you in the SQL introduction that relational databases define the structure. We have to predefine the structure. So when we create the table, we define the structure of the table. We do not define structure at database level or at schema level. The structure is enforced at table level only. So let's say these are the columns. So these are the different column names. We have defined only 10 columns in this particular table. So this is the structure of the table, meaning that this particular table, let's say this orders table, it contains 10 columns and these are the names of the columns. Now after that, what we do is that we should also mention what type of value the columns will store. Meaning if you look at ordered date and delivered date, it looks like they deal or store date values, and the price is basically amount. So obviously the price is different than date. Same is the case with order ID and customer ID. So let's say these are the values. This is the first row and this is the second row. Right. So the order ID has 1200 and 1400 as the value. Customer ID has 100 and 138. This is how the date looks like, order date and delivered date. The status is a little different. It is pending. This is delivered. Then we have prices in decimal values. Then we have location, quantity, sold by, discount. Right. So if you see, the values of the columns are different. Right. So this also contains in the structure, meaning what value each column would store. And we use the create table statement. And this is the SQL statement. So create table, after we mention create table, we mention the column names. Right. Now, as I said, what type of value the columns will store, we have to mention that also. But how do I mention that? So it looks like order ID contains numeric values and so does customer ID. But order date and delivered date contain date value. Status is P and D, which is basically text, right? And price is decimal because we have decimal numbers. Location is also something like character or alphanumeric. Quantity is again numeric. Sold by is again text. And discount is again numeric. So we have to mention that each column would contain these type of data. And that's where data types come into picture. So there are various data types available, and I'm talking about PostgreSQL, but the data types would be similar in all the databases because remember, all are ANSI SQL compliant. Just a primer before going into the data type. 1024 bytes is equal to 1 KB. I have just put the value, what is 1 KB, 1 MB, 1 GB, etc., because these will be needed while defining the column types. First, we have small int, which caters to numbers. And the minimum and maximum value that you can store in small int is this one, minus 32768 to plus 32767. So if you know that you'd be storing numbers or numeric values in a particular column whose value would not be less than this or more than this, then you can use small int. And small int uses 2 bytes in storage. So when it is stored in disk, any column with small int data type would consume 2 bytes of storage. And if you need more value, then you can use integer. And this is the minimum and maximum value, and it takes 4 bytes. If we define a column with data type integer, when we store it in the disk, it will take 4 bytes. And if you have values more than that, you can use big int also. So which is with minimum value of this and maximum value of this. And the size is 8 bytes. Then you have decimal also, like price that we have seen in the previous tables. You mentioned decimal followed by precision and scale. For example, decimal 10 2, it means the total size is 10. Before dot, there will be 8 digits, and after dot, there will be 2 digits. Something like this, 128.12. We can also define decimal values using numeric. In numeric also, you can mention precision and scale, and the size would be p bytes. Depending on the precision, the size would be defined. So in this case, it would be 10 bytes. And if we mention, let's say 8,2, it would be 8 bytes. And this is how we define the decimal data type or numbers with points in it. Then we have text values like character, varchar, etc. And we mention the size here. So if you know that certain value would contain these many characters only, we can mention that number here. So let's say the state code is only 2 characters like KA, CA, TX, etc. So you can mention state as char2. And if you do not know how much that would be, you can mention varchar. So let's say if we mention varchar as 10, that particular column can contain value from, let's say, 1 byte to 10 byte. Then you have text also, which is variable unlimited length. And we have date data type also, and size being 4 bytes. And this is how the dates are stored. Then you have timestamp, time also, sorry. And the time is stored as hour, minute, and second. The size is 8 bytes. We can also mention time zone, and if we use time zone, then the size would become 12 bytes. Then we have something called timestamp, which is a mix of date and time. And in timestamp, this is how the data is stored: year followed by month followed by date, hour, minute, and second. There are dash in the date and colon in the time, and the size is 8 bytes. We also have something called boolean, and it can contain value like true and false, or 1 and 0, or yes or no, and on or off. The size is always 1 byte. So these are the various data types that we can define for columns. Of course, there are a lot of other advanced data types which I am not mentioning here. Okay, we have one more data type like binary also, which contains binary variable string. Now let's go back to the previous slide wherein I told you this is how we create table, and let's say this is the structure of the table. So now you know the data types, right? As I know the data types, we can define the columns using the data types. For example, order ID. Now order ID can be very big, right? Because it can be continuous. The same customer can actually order multiple times. It can be billions if not less. So let's say the order ID, we mentioned big int because we know the number can grow really big. But if we talk about customer ID, the customer ID should not be that big. Define customer ID with big int data type. I could have mentioned int also. There's nothing wrong in mentioning int or integer. Now order date, it would be date data type. Delivered date would be also date. Status would be character 1 because we know that it will only store characters like pending, delivered, in progress, in transit, etc. And the value can be only 1. So that's why I have mentioned char 1 here. But price would be decimal. And I'm mentioning decimal 10 comma 2. So the precision is 10 and the scale is 2, which means before the dot 8 values and after dot we can have 2 digits, and before dot we can have 8 digits. Location is also text, so we do not know the length. Quantity would be, let's say, integer. Small int would have been done also because I don't think anyone would basically buy more than 32,000 items in a single order. Sold by is again text, and then we have discount. And in discount, I have mentioned decimal 42. Why 42? Because before the dot we can have 2 digits, and after the dot we'll have 2 digits. Of course, the discount cannot be more than 100. No one will give you 100% discount, right? So again, 99% is also very high. And this is how we create tables. Of course, I'll show you all these in the hands-on also. But just to clarify all the things conceptually, this is how we create table and define the structure. So now you know what a structure is. Structure is basically the name of the columns and the number of columns and along with its data types. So the column names, the number of columns and its data types are used to define the structure of a table. And we define structure only at table level. Let's talk about the important thing in the definition of the database that I mentioned in the introduction, which is RDBMS. And RDBMS stands for Relational Database Management System. And I have been talking about relational databases a lot, right? So all the databases that I showed you were relational in nature. Now, what is a relation? A relation is translated to referential integrity in technical terms. But let's tell you about relation. First of all, before going into the relation, let me tell you the primary key, what a primary key is. Primary key is used to uniquely identify each row. It's a unique identification of each row. So let's say this is the table and we have order ID, customer ID, etc. This is orders table and this is the table, right? Now what would happen is order ID has to be unique, right? Because order is something which defines your business. And no two orders can be same even if that is by a single customer, because if two orders are same, how do you track that particular order? There will be a lot of confusion, because when, let's say, you're using an online retail business or you're creating an online retail business, Now, if you have to deliver something to your customer, how do you know what has to be delivered? The thing that has to be delivered relates to a particular order which was made by the customer. So, whenever you go for online shopping and you add something to your cart and then place an order, that order by itself is unique. So, if you place the order and then you place one more order, those two are not unique even though you have placed it. Order is the unique identifier of your business. This is what uh, runs your business. So that's why each order ID has to be unique, and we can use order ID as the primary key. And this is how we define the primary key. The constraint followed by the name of the constraint and then primary key, and in bracket we mention which column would be the primary key. So in this case I have defined order ID to be the primary key. So what would happen is that you cannot have duplicate value in order ID. So if you try to insert duplicate values in this particular column, the database will give you error because you have defined a primary key here. Now the next thing is customer ID. So as you can see here in this table, I have mentioned customer ID. Why customer ID? Because you have to deliver this order. The question is whom to deliver. Whoever has ordered the order, it has to be delivered to that person. Now how do you know who that person is? So that's where customer ID is. But in this particular table, I do not have any customer information. So how do you deliver the order to that particular customer without knowing the address? So you need to know who that customer is, what is that customer's phone number, email ID, or address. So what we do, we define maybe a separate table where we put all the customer information. Now, why do you have two different tables? For that, you need to know data modeling. I have a separate chapter on data modeling. So if you're interested in knowing that, you can go through it. In this case, what we are doing, we are defining a different table for customer. That table contains customer ID, name, customer address, email, phone number, etc. and a lot of other columns. So now these two tables have to be related because if you want to find out where to deliver this particular order, we need to know the address of that order. An address is attached to a customer. We know which customer has placed that order, but we do not know the address because address is in a different table, which maybe is the customer table. Now what we do is that we relate these two tables. And how do we make the relation? Using a common key or a common column. So in this case, the common column, if you see, is the customer ID. So we use customer ID to relate these two tables. Now, of course, I'm talking about relation here in human terms, but in database, these are stored using pointers and other things. But what happens is that when you create a table, we define that this table is related to this table, and database would automatically create those pointers. We do not have to do anything as such. And how do we define the relation? We define the relation using something called foreign key. So in this case, customer ID is the foreign key for the orders table, but customer ID is the primary key for the customers table. But as we are trying to define orders table here, this is how we will mention constraints order underscore fk. This is the name of the second constraint, and it is the foreign key. And what is the foreign key? That is the customer ID in orders table. And this customer ID references customer table and the customer ID column in the customer table. So why do you have to mention this column name? Because you might decide to name this column as just ID instead of customer ID. So that's why you have to mention the column name also. And this is how we relate multiple tables. I am showing you only two tables, but there can be a lot of tables in a particular organization. And there's a separate role for this, which is called data architect or data modeler. So as a data engineer, you might have to know data modeling also. So that's why I have put the chapter for data modeling. Please go through it. In data modeling, I have talked about ERD diagrams, normalizations in OLTP databases, and dimensional modeling for data warehousing systems. Coming back to this topic, so we have defined this constraint, and here I'm saying that foreign key is customer ID of orders table, which references customer table, and this particular column of the customers table. Now you might imagine that if I have to define this orders table, I have to make sure that customers table is already available. Otherwise, the reference would not happen. Otherwise, the pointer cannot be created. Because in this table definition, I'm saying that the orders table is related to customers table using the customer ID. But if the customers table is not there, then this create table statement will give you error. So if you are creating tables like this, you have to create these tables first. And these are called parent tables. And this particular table is called child table. Now in this case, the customer ID would be parent table and the order ID would be child table. And this is not only for creation of tables, you'll have to load the parent tables before the child tables. All right, so that's what relation is, or in DBMS term, it is called referential integrity. Now let's say if you want to alter certain tables because you want to change the, let's say add a column or remove a column or change the data type, etc., etc. So you can use alter tables for that. We use alter table to add column, remove column, change a particular data type of a column. We can rename column also. And this is the syntax to add a column. We mentioned alter table followed by the table name, and then or add column. This is a new column and the data type of that column. Similarly, we can drop a column also. We can alter table to change the data type of the column also. Here what am I doing is I'm altering the table orders and I'm altering the column status and I'm changing the data type to char1. Maybe earlier it was text. So these are the various operations that we do using alter tables. I'm introducing one more concept here, which is called identity columns. It does not belong to order tables, but it typically comes in the table definition. So what are identity columns? These are used to generate values for a particular column automatically. Let's say auto incremental value. So you are creating a column, it starts from 1 and then whenever you insert a particular row or any rows, the value would automatically increment. That's what auto incremental is. This is how we create identity columns, order ID followed by the data type, and we mention generated always as identity, meaning the value for this particular column would always be automatically incremented and generated by itself. We can mention default also, generated by default as identity. In that case, what would happen is that if you do not specify any value for that particular column, then the value would be incremented. But in case of always as identity, you do not have to specify any value for order ID and for any rows. So for all the rows, order ID would be generated automatically.